Today we'll be looking at a thing called the Pythagorean theorem. It deals with right triangles and their sides. You'll be able to apply the Pythagorean theorem to right triangles as well as right triangles within quadrilaterals and other triangles. Let's take a look here. First we'll look at some terminology, some vocabulary. First of all, our first term is a right triangle. What is a right triangle? A triangle that contains one angle that measures 90 degrees. And you can see we make the 90-degree mark with this little box right here, a little corner of a box. There's the 90-degree angle. This is a right triangle. Now the sides have special names. There are two sides called the legs. These are the sides of the triangle that form the 90-degree angle. They're bold right here in this picture, but they even make like a big L here. Those are the legs. There are two legs in a right triangle. And we label them A and B right here. Next, the last side, the third side of the right triangle, is called the hypotenuse. It is considered the longest side always in a right triangle, and it is opposite the 90-degree angle. Here's the 90-degree angle. Opposite that angle is the hypotenuse. I usually figure out what the legs are here, the two that make this right angle. I highlight those two sides that make this 90-degree corner here. Those are the legs, and then I know the other side is the hypotenuse. That's important, knowing these, which ones are the legs and which ones are the hypotenuse in this formula we're about to use. Now I'm going to skip the little example on that first page and go to Pythagorean's theorem on page 286 here. On a formula chart, Pythagorean's theorem is written a squared plus b squared equals c squared. What it means is the length of one of the legs squared plus the length of the other leg squared will equal the length of the hypotenuse to the second power also. So we're going to see how to use this formula to find missing sides of a right triangle. So I am skipping example 1. We will do that later. I'm going to do just the basic problems right now. So we're going to example 2 and seeing how this formula is used. So we'll look at example 2a here. We've got a right triangle where we know the legs, but we're missing the hypotenuse. So again, if it helps you, you can highlight those legs. All right, the two sides that make this right angle right here are called the legs. Okay, they're the two that go over here together. The hypotenuse is all alone in this formula, the c squared part. So to set up this formula, it says take one of the legs to the second power plus the other leg to the second power, its length, which is 7 in this picture, will equal the hypotenuse, which is x, raised to the second power. One of the most common mistakes is not to raise everything to the second power. You got to take this side, how big it is, to the second power. 3 squared means 3 times 3, which is 9. So I usually just put this into my calculator and get one answer for it. I'll put in 3 squared plus 7 squared, hit enter, and that equals 58. Now we know 58 equals x squared. We want to know what x is. So to get rid of the square or the power of 2, we use the square root. So it looks like this. We've taken the square root of both sides. On this side with x, all the square root does is cancel out the square and leave us x. We put in our calculator the square root of 58, and this one doesn't come out exact, so we round it to the nearest tenth. Comes out to 7.6. So you should practice this with your calculator. Make sure when you put in 3 squared plus 7 squared, you get 58. And when you take the square root of 58, it rounds to 7.6. Get help if you need it. Okay, that's all there is to it. Leg squared plus leg squared equals hypotenuse squared. We get one number there. You'll see later what happens when we don't know one of the legs. Let's look at the B example now. The B example, we don't have just a right triangle. We've got what looks like a rectangle here, and they want to know the diagonal of this rectangle is x here. So if we cut this into this right triangle here, we got a right triangle here, we know one of the legs is 7. This other side is equal to the same as this side because it's a rectangle, so this side's 24. So now here we have these two legs again. We're going to solve for the hypotenuse, or the diagonal of this rectangle. So again, these are the two sides that make the right angle here are the legs. So we're going to take them, square that leg, 7 to the second power, 20 plus 24 to the second power equals the hypotenuse to the second power. Again, you're just going to put that into your calculator, try it, and you should get 625. Now again, to get rid of the, we want x, not this x to the second power, so we take the square root of both sides. So put that into your calculator. What is the square root of 625? We should get exactly 25. So this diagonal is 25. Take a look at our next example. Example 3, a similar thing. You might get a little confused that this 5 square roots of 2 here. This is the length of this diagonal. We've got a square here because all the sides are marked congruent here with these congruent marks. So the side is what we're looking for. It is x. Okay. So again, we can have a right triangle up here or down here, either way. If this side is x, this side is also x. So our two legs are both x here, because it's squared. And our diagonal or hypotenuse is 5 times the square root of 2. You'll see how to set this up and put it in the calculator. But of course we start off with our squaring each of the legs and add them up. So one leg is x squared, plus the other leg squared, x squared, equals the hypotenuse squared. And look how this is written. This is exactly how you're going to put it into the calculator too. Parentheses around what it is. Your calculator knows this means 5 times the square root of 2, and then close the parentheses and the power on the outside. So if you put this in the calculator just like this with the parentheses, 5 square roots of 2 squared, and you should try it, you should get 50. Over here we have x squared plus x squared. 1x squared plus one more x squared makes 2x squared. So on this, we don't want to get rid of the power first with square root. We want to get rid of this 2 in front, this 2 that's multiplied. So the opposite of multiplication is division. So we divide both sides by 2. And that cancels out over here and leaves us with just x squared. And 50 divided by 2 is 25. Now we've got the x squared by itself. That's when you do the square root. Okay? So we take the square root of both sides. Of course, this just cancels out the square over here and we get x. And the square root of 25 is 5. So each of these sides are 5, or all the sides in the square are 5, or x equals 5. All right, I'm going to pause this now and we'll do another video for some more examples in a minute. I'm getting a little long here. So you'll go to part 2 and after you finish these notes. Remember, if it's going too fast, you can always pause it, take a look at it. Ask any questions if you don't understand how these equations are getting set up or putting them into your calculator. Ask them now before you get to the practice that I want you to do on your own.